In a previous lecture, we have seen the scalar product and its properties. Now, vectors can be also multiplied by using another method, which is called as a vector product. The answer of the scalar product was a scalar quantity, therefore it was called as a scalar product. But the answer of the vector product will be the vector quantity. Okay, therefore it is called as a vector product. Now, if I have the same two vectors, say vector A and vector B, and if they are making an angle theta with each other, then the vector product or the cross product, so vector A cross vector B, it can be given by the product of their magnitudes and sine of the angle between them. The direction of the resultant vector is given by right hand rule. Now suppose if I hold my right hand like this, okay, so this is vector A and this is vector B, then the vector product direction will be directed in the my thumb direction. Okay, so if I so this is my forefinger. Okay, so the forefinger denotes one vector, okay, and the middle finger denotes the another vector. Then the resultant vector, okay, of the vector product or the cross product of the resultant vector will be denoted by my thumb. So this is the right hand rule. So this vector product is not commutative. So vector A cross vector B is not equal to vector B cross vector A, but yes, it is distributive. Vector A cross vector B plus C, so this will be vector A cross vector B plus vector A cross vector C. Now suppose there are two vectors which are parallel to each other, so the angle between them will be 0. So we know that sine 0 is equal to 0, therefore vector A cross vector B is equal to 0. The vector product between the unit vectors with itself will be also equal to 0. So I dot I j cross j and k cross k will be equal to 0. So the I cross I, j cross j and k cross k will be equal to 0. So as we know that the direction of the resultant is given by the right hand rule, it means that the resultant vector is perpendicular to the both vectors. Suppose this is I, this is j and this is k. So I can write, if you go in this clockwise direction, if I take I cross j, so it will give you k. If I take j cross k, it will give me vector I. If I take k cross I, it will give me unit vector j. But we know that this cross product is not commutative. So if I take j cross I, so it will give me minus k. If I take this k cross j, it will give you minus I. And if I take k cross I, it will give me vector j. Now let us have two vectors which are represented in their perpendicular components as axi plus ayj plus azk, and there is another vector bxi plus byj plus bzk. Then their cross product is given by vector A cross vector B, axi plus ayj plus azk. bxi plus byj plus bzk. So let us take a cross product of each and every term with the bracket. Plus I will write it plus azk you just remember this diagram. Now if I take, we know that, so this I dot I is equal to 0. So this term, first term will become 0. So I dot j will give me k. So this ax by k plus ax bz I cross k will give me minus j plus, so this is j cross I, as I am going anti-clockwise, it will give me minus k. So this is ay bx into minus k. J cross j will be 0. So j cross k, so this j cross k will be I plus ay bz I. When I take this k cross I, that will give me j. So this will be az bxj plus this k cross j will give you minus I az bx minus I plus az bx into k cross k, that will be equal to 0. So we are going to get these terms and I can write it as, so this is ax by k minus ax bz j minus ay bx k plus ay bz I plus az bx j minus az bx I. So 2 k terms, 2 j terms and 2 I terms. So that will be equal to vector I, vector j and vector k, ax bx, ay by and az bz. So this will be the cross product of the two vectors.